Hello and welcome back to our program, applying the 7 steps of data analysis to produce a quantitative research study. William Bannon of StatsWhisper here with you again. Okay, in this presentation today, we are going to review steps 4 and 5 for sample study 2. Recall sample study 2 is our quantitative research study with a categorical dependent variable. Okay, so step 4 is univariate analysis, and step 5 is bivariate analysis. Okay, again, if we look at our 7 steps of data analysis listed, we are at step 4 univariate analysis and step 5 bivariate analysis. Okay, recall, just like last week, step 4 in our parallel between data and data analysis, step 4 is the uni level, uni meaning 1. So uni data analysis is the study of one data, or specifically the characteristics of one data. If you've ever watched the shows like The Bachelorette, that's what the first shows are concerned with, right? They present the daters in The Bachelorette, and they each speak and describe themselves. So they present their characteristics, just like Bob, Bachelor Bob. From Ohio, likes hiking, long-term relationship, seeker, right? And then data analysis is the same thing, except with variables. So univar, one variable, we're presenting the characteristics of one variable at a time, such as happiness measured on a scale of 1 to 5, average score 3.2, min-max, highest and lowest scores 2 to 4, right? So we're just presenting the characteristics of each variable one at a time, right? So you could say we're using univariate analysis to generate a profile of each study variable to understand each factor prior to inferential analysis. Because like we said earlier, once we get to inferential analysis, we can't see the characteristics of each variable. We see the relationship between variables. So this is our chance to see that dimension. So we have 4 variables within sample study 2, right? So we have the 3 predictors on the left, the covariate variables, education and income level. The independent variable, do you live with a dog or a cat? And now on the right, our dependent variable, happy, yes, no. So to perform univariate analysis for these 4 variables within sample study 2, see the univariate test key. Right, so again, just like last week, univariate test key. On the left, we have the variables we're looking at, categorical and continuous. And on the right, under univariate test, it indicates we're performing a frequencies test for each. Now, the notations for the categorical 1, we're looking at the numbered percentage within each category. And the notation for continuous with the 2, we're looking at the mean standard deviation and minimum and maximum scores. Now, once we plug in our variables here, right, we can see there's another variable under categorical, right? So just like last week, sample study 1, we have education level and lives with a dog and cat. But now, under categorical, also we have happy, because it's a yes-no categorical variable. And the only continuous variable under that is income level. Now, to do univariate analysis, right, we've done frequencies a bunch of times. We could do it in SPSS one more time, right? So we go to SPSS. Remember, we go to Analyze, Descriptive Statistics, Frequencies. Now we have our study variables, but now instead of happiness, we put in happy, right? And then we paste it, and we go and highlight it and run it, right? And we will get our output, which is also right here, right? So there's the first box in the frequencies, the statistics box, right? And that's more useful for describing our continuous variables, right? So what do we want to look at here, right? Income is the only continuous variable. So we're looking at the mean, 52.05, which is approximately $52,000. It's measured in thousands, right? The minimum is 22,000. The maximum is 78,000, right? So we have our continuous variable descriptives, which we can present in our table. And then we have our categorical variables, such as, again, education level. And we want to look at the columns for frequency and valid percent, right? So for example, college, the frequency is 29. There's 29 study participants at the college level, and that's valid percent, 29% of our sample, right? So next, we again look at, do you live with a dog or a cat, right? And again, we look at the frequency and valid percent. So for example, cat, there's 53 study participants live with a cat under frequency, and under valid percent, that's 53% of the sample. Now we've added, is the study participant happy, right? And this is why this is so important to look at our univariate statistics. So this is our outcome. Now, what would have happened if we had yes, no, and under yes, there was only 7 study participants that were happy and 93 were not, right? That would be a lopsided distribution. So that's why it's important to look at the univariate statistics and the characteristics of the variable prior to inferential analysis. But we see here, right? Yes, we have 31 yeses. So the frequency is 31. 31 study participants are happy, which is 31% of the sample. So roughly it's 2/3 of the sample that are not happy versus 1/3 of the sample that is happy. And that's a relatively even distribution, right? And we put that in a nice APA style table, and we add to it from last week, is the study participant happy, as the third variable. Now recall, right, step 5 in our parallel between data and data analysis, step 5 is the by level, right? So in by data analysis, by meaning two daters, right? The bachelorette is considering who she has a significant one-on-one relationship with, right? So you can see bachelor 3 says not sig, not a significant relationship, right? So this is all by consideration one-on-one significant relationships. Now the ones that don't have a significant relationship are eliminated in the bachelorette show and do not progress to the next round. And that's pretty much the same with bivariate analysis and data analysis. So in data analysis, bivariate, bi meaning two, is a relationship between the predictor and dependent variable. For example, the first one is gender and happiness, and it says not sig. So there's not a significant relationship between gender and happiness, so gender will not go to the next step, step 6, right? So in both instances, we're looking at significant one-on-one relationships, and if the relationship is significant, the relationship goes to the next round. But if the relationship is not significant, the bachelor or the predictor, right, does not go to the next round. And recall, we also call this the by level, BYE, because in the bachelorette, the data analysis, this is where she says bye to all the relationships that are not significant, all the one-on-one relationships that are not significant. And in data analysis, we say bye to all the one-on-one relationships between the predictors and the dependent variable that are not significant, such as gender and positive attitude. Okay, so we're using bivariate analysis to identify significant one-on-one relationships. Remember, significant here is set at p is less than 0.05 between the predictors, the covariate and independent variables, and the dependent variables, so we can select predictors for step 6 multivariate analysis. Okay, so again, we put our study map up, and then we put text boxes in where we're testing relationships. So each arm or each arrow, depending on what you'd like to call it, represents one bivariate test where we're testing the bivariate relationship. So test 1 is testing the relationship between education level and happy. Test 2, income level and happy. Test 3, do you live with a dog or a cat and happy. So this is a good way of keeping track of the results of our tests as we go through them. Okay, so to perform bivariate analysis for the 3 variable relations, right, the 3 arms we just looked at, within sample study 2C, the bivariate test key. So again, when we look at the bivariate test key, we're going to consider 3 variable structures. 1 is continuous, 2 is categorical with 2 categories, like living with a dog and a cat, and 3 is categorical with 3 or more categories, such as education level, because we have high school, college, and perhaps other. Now, as we said, typically bivariate analysis will involve 4 tests. 1, the t-test, 2, the chi-square, 3, the ANOVA, and 4, the correlation. Now you're going to see, since we have a different structure-dependent variable, we're going to use different bivariate tests relative to sample study 1. So here's the bivariate test key again, recall. Now let's plug in our variables. Right? So we have the 1 dependent variable, happy, yes, no, and our 3 predictors, the 2 covariates and 1 independent variable. So let's see the relation between them. So you'll see here now, we do not need, which we used in sample study 1, the ANOVA or the correlation, because our dependent variable is dichotomous, is categorical, right? So what we need is variable A, income, is continuous, and variable B, right, this is our dependent variable column, is categorical with 2 categories. So we use the t-test, right? And the other relationships are all categorical. So categorical and categorical, we use a chi-square. So education level is categorical compared to happy, yes, no is categorical. So we use a chi-square. And live with a dog or cat is categorical compared to happy, yes, no categorical. And again, we use a chi-square. So this time we only need 2 of the bivariate tests. So we will now implement each of these bivariate tests for sample study 2, the t-test and the chi-square. So the chi-square is used to see if proportions within categories differ significantly by 2 categorical variables. You'll see what I mean in a minute. So our research question is, does the percentage of happy people differ significantly by education level? Now, here we have the path to implement our chi-square. So we have it written down, but let's do our demo where we actually do it live right now. Okay, so we go back to SPSS. Now there's a couple of ways to do it. So analyze descriptive statistics and then crosstabs. right? Now we always want the dependent variable in the column, right? So the dependent variable is the study participant happy, right? So that's in the column. Then we want to put the other variable, education level, in the row. Under statistics, we click that and we click chi-square. Under cells, we click that, and under percentages, we click row, continue, then we paste it. Then we go to our syntax and highlight it and run it. I click, and then we get our output, which is right here also. So that's the chi-square result output. So what numbers do we want to concentrate on? Let's highlight them. There we go. So in the bottom box, the second box, the last column, says ASYMP sig two-sided, right? So that's our significance level, and it's less than 0.05, meaning there's a statistically significant relationship. So if we go up to the first box, right, the highlighted column is yes. So in response to it, is the study participant happy? Yes. So now we can see the percentage of happy study participants within each group of education level. So the first one is high school, right? Education level, high school. And we go over, and we see it's only 3 people, but it's 9.4%. So 9.4% of the study participants at a high school level education are happy. Then we go down to C, college, right? And we see that 13.8% of the study participants with a college level education are happy. But then when we go to graduate school, we see a big jump. So 61.5% of the study participants that went to graduate school are categorized as happy. So there's a significant relationship where it seems that as education increases, you're more likely to be happy, particularly if you went to graduate school. So there is a significant relationship. So the answer, right, for test 1, we fill in our box, test 1 significant. So there's a significant relationship between education and happy. So include that in the next step, multivariate analysis. Right, then we go back to our t-test, specifically the independent samples t-test. And that's going to tell us if significant differences exist in income scores among people that are happy, yes, no. Study participants that are happy, yes, no. So here is our path for independent samples t-test. So we can actually do that again in SPSS, right? So we go to Analyze, Compare Means, Independent Samples, right? Now we take out happiness, what we had in sample study 1, and we put in income, and we take out that variable, and we put in, is the study participant happy? And remember, it's coded as what? Not 1 and 2, but 0 and 1. Happy, yes, no, which is always 0, 1. So we change that to 0, 1, continue, and we paste it. And then you go to the syntax and highlight and run it. And we would get our output, which looks like that. Now, which numbers do we pay attention to? Here we go. Now recall, first, when we look at the significance in the middle column in the second box, right? Note the Levene's test is statistically significant, less than 0.05. Therefore, we use the values in the second lower row rather than the top. Now, they're both statistically significant, but that doesn't always happen. So the results are statistically significant, right? And it's saying that there's a higher mean income here for happy, yes. So study participants that are happy have a mean income of over 300,000, and the mean income for participants that are not happy is almost 145,000, All right, so there is a significant relationship between income level and happy. So we fill in our study map to indicate that. Now, lastly, we're looking at our independent and dependent variables. So the chi-square again to see if proportions differ between two categorical variables. And we're looking if the percentage of happy people differ significantly by living with a dog or a cat. So there's our chi-square again. So if we go back to SPSS, you don't have to do everything over again. You just have to switch. So descriptives, crosstabs. You just take out education level and you just put in the living with a dog or a cat. Right? And then paste and then run it. Okay? So the output will look like this. And where are our numbers? Right there. So in the bottom row, we see the significance in the last column of the second box is below 0.05, meaning there's a statistically significant relationship. And if we look at the center column on the top box, we see under yes, so the first row is dog. On yes, 48.9% of people that live with a dog are categorized as happy. But look at this, under cat, only 15.1% of the people that live with a cat are categorized as happy. So there's a significant relationship where people who live with a dog are more likely to be happy than people that live with a cat. So we fill that in. Now we have our bivariate analysis completed for sample study 2. Right? So, repeating our notes, we use bivariate analysis to identify significant one-on-one relationships. Again, we did not note the effect size like sample study 1 because we were interested in the dimension of significance, right? We will see the effect size between the predictors and dependent variable in the multivariate analysis. And if you're interested in the bivariate effect sizes, they are covered in the text. But again, note, you can see here what variables are significantly related to the dependent variable, but you can't see which is the strongest predictor of the dependent variable. Right? That will be revealed in step 6, multivariate analysis. Okay, so next week, multivariate analysis. Step 6. Thank you for watching, and I will see you then.